welcome. I think I finally got all my elaborate demo stuff set up, so we'll see if it actually works later. I'm Matt Porter. I'm with Konsulko, and this is building IoT systems with OpenHAB, and we'll jump right into it. Thanks for coming. A little overview today. We'll talk a lot. Always need a little bit of history. I like to have a little bit of history. I love history. So we'll start with a little timeline of IoT stuff. Then we'll talk a little bit about frameworks and protocols that are out there. And then we'll jump right into the main theme of this, which is the actual OpenHAB open source project. We'll talk architecture, some features it has, how to configure it, complete with exact steps, and some examples, and then we'll dive into a demo. And I didn't mention on here, we'll talk about some things that are coming up in OpenHAB, future directions for it, and so forth. So, we hear a lot about IoT, and I want to prove in some manner with history that it's been around forever. So we already had things online back in 1969 on ARPANET. They were things talking to each other. There was 4 of them then, talking NCP. So then we really had the internet born, right? 83, when they were talking TCP/IP. Then, major event, the Trojan Room coffee pot goes online in 1993. It was only a local webcam in 91. 93, it goes online, and coffee pots are an important part of our lives. So where did this crazy term come from? Kevin Ashton from AutoID, I think he was at P&G at the time, coined that term in some internal presentation in 1999. So it's been a while since that term showed up. Of course, as we know, the media goes into this complete frenzy. We've got to hear this term over and over and over and over, right? It just will not stop. OpenHAB comes along as a smart home automation framework. In 2010, the project started, so it's a fairly mature open source project at this point after 5 years. And to bring us up to the present, Thomas Rucker's Tweeting Toilet goes online, ushering in the Internet of Toilets in 2014. You can go read the article that I've cut off on the bottom, trying to cram this in, there in Computer World. So yeah, could be Internet of Things, could be the Internet of Toilets, depends on how you look at it. So that brings us up to the present. We got a lot of buzz going on. It's a big theme at this conference. Perhaps I even stuck IoT in the title to pander to the acceptance committee. Effective. I know how to play, guys. All right. So there's a lot of frameworks. You're hearing a number of great presentations this week about these frameworks. AllJoin is there. There's a presentation on that and IoTivity as well. Frameworks for distributed applications, frameworks for machine-to-machine communication means the same thing at the end of the day, right? You're building applications in loosely coupled systems. There's a Cura that's an OSGI based framework, so Java containers. Right, and that's run under Eclipse. There's also a Lua-based framework that they have that's tightly coupled with that, or can be. And then what I want to talk about is there's a strong relationship between the frameworks that have been around for a while. There's been things like Mr. House, and OpenHAB's been around a while, that are home automation frameworks. Now, the big guys out there are getting into this, right? You've got Google with their walled garden and Apple with their walled garden and so forth. But there's been a lot of open source and other commercial frameworks out there. But we'll talk about OpenHAB today. There's a lot of protocols. People are always talking about what the best protocol is, usually for that communication between nodes, back to gateways. There's a lot of different models that you can build these systems because the use cases are all very different, right? So there's CoAP that works very well on smaller size devices. MQTT, I'm sure most have heard of MQTT, also very low overhead, works great on constrained devices like these sensors and so forth that we're putting out there. And then if we look at the higher end, we start devices with some resources. We can do RESTful HTTP protocols and deal directly with those cloud services. Another one is XMPP. It's pub sub. It's one nice thing. It's got built-in authentication. You'll probably know that historically as the protocol from Jabber, used in a lot of peer-to-peer communication networks. So there's a lot of different things. There's many, many, many more. Okay. Each of them have their pluses and minuses. Everybody wants to know what's the best framework, what's the best protocol. It's what meets your use cases, your requirements, right? So talk a little bit about MQTT. That's part of what I use in some of my work with OpenHAB. MQTT is now an Oasis standard. It started off as an IBM-backed protocol. At version 3.1.1, it became an Oasis standard. It's a publish-subscribe model of messaging, and it's a hub-spoke model. So you've got a central hub that's routing these messages, and the hub, the MQTT brokers, you may hear of those tools. Those provide that central hub. And one very well-known one that you'll find in the open source community is Mosquito. The 1.3.4 version of Mosquito supports the version 3.1.1 version of the MQTT protocol. So talk about why you often see these where, well, it's low overhead. Well, let's actually look at it. As you can see, there's a fixed header that's required in any MQTT packet. And then there's a variable header and a payload, okay? In most of the packets, you don't have the variable header. If you want to do something more complex, you can add additional information in a variable header. Most things, you're just using this fixed header. And if you look at how that's broken out below, it's 2 bytes. So you've got 2 byte overhead on top of your packet if you have a small length payload. So very low overhead, easy to frame and use in very constrained devices, low cost sensors. All right, so let's get into OpenHAB, the basics. So it's free and open source automation software. And I dropped home out of that name because it doesn't have to be just for home. It could be used like most IoT applications, whether it's in the home or in a workplace, in an industrial setting. It's applicable anywhere there. You can find it at openhab.org. It's under Eclipse public license. And it's written mostly in Java. Ugh, right? Yeah, I know everybody's, I had a comment on Google Plus already about what a horrible hog it is, and I agree. So it's written mostly in Java. Jetty, it uses one of the OSGI container tools from, we'll talk about that a little bit more, the architecture. But it's a central automation hub. A lot of IoT applications are not direct devices going back to some cloud service, but they may need to aggregate in a home hub or a central hub for whatever your entity that you're covering the sensors. And so I like to think of it as an aggregation point and the hub is typically that system that has more resources connected to the network. Hardware protocol agnostic. there are many bindings, and we'll talk a bit about what bindings are, but you can look there. There are bindings to pretty much every protocol, both open and proprietary, out there on the market. From Bluetooth beyond, we'll get to that in a second, but and it's a component-based architecture. So because it's OSGI based, each component in the system has well-defined interfaces, and they're packaged up as OSGI bundles. All right, so the obligatory layer cake architecture diagram. As we know, all complex architectures can be represented as a layer cake, right? And so what we see here, and this comes right off of OpenHAB's architecture page, but what I want to really focus in on are the key areas. What you'll see is that there's an OSGI framework in green, and then the core, you have a core of OpenHAB, well layered, and then you have four major areas up in the yellow. There's automation logic, so there's a whole script and decision-making engine, parsing engine that's one block. There's the protocol bindings, that area that's all these different protocols from Bluetooth and on that it aggregates together, allows you to run your decision-making engine logic for your application on it. There's an item provider. Every sensor or switch or whatever device that you're putting out in the network to aggregate together with this hub is represented as an item. And we'll talk a little bit more about the definitions of those coming slides. And then user interfaces. So the user interfaces are completely modular. So looking at this a little bit more closely, core part of OpenHAB is the concept of the event bus. There's an asynchronous communication bus, the event bus, that all of these pieces can monitor. You have a repository, which is the piece of the framework that allows persistent storage. And it's all done in an abstract way, so you can plug in any database you want, logging mechanisms. It could be a simple file. There's methods for each of those. So everything is defined at an abstract level to allow you to choose what sort of database scheme you want to use for persistence across power downs. If you're powering down the hub, that type of thing, you want to keep the state of things. Items. So I promised we'd talk items. So that's directly mapped, any object that can be read or written, right? It's a sensor, a switch you're controlling, a water pump, okay? Those are all defined as an item when you configure your OpenHAB system. And each of them has a type and a state. Next we have the bindings, and those simply are things that translate event bus events to and from external systems. So if you have a fitness tracker on with Bluetooth, okay, you can do proximity sensing when you walk in the house, and an event, a binding, right, is written, so when that address comes in proximity and it senses that, it can take action based on the event landing on the bus. So the binding takes care of things happening and puts them on that event bus asynchronously, and everything else in the system can monitor that. Finally, actions. Actions are programmatic methods in which you can interact with the outside world in some way. So this is typically you write a script or a rule, and we'll talk more about that, and you can generate any sort of complex actions and interact with cloud services or buzzers or whatever you want to use as an I/O method with your humans. So yet another architecture drawing, and since I'm really bad at drawing stuff, I just borrow them off of the OpenHAB site. You can find all this information there. So what does this look like? I showed you in text. You have the event bus, and if we have a number of bindings. KNX is another set of home automation type sensors and switches and so forth. RS-232, there's a binding so you can talk to certain devices, since RS-232 will never die. Yes, I agree. And it works, right? And so you can see the bindings can interact. They can give status updates, and they can receive commands off the event bus. And then the same thing, there's a logging area. It has access to the event bus, so it's gathering the events and logging based on the configuration. And the same thing's true for the repository, which I mentioned is the abstract way that persistence is maintained. It's able to handle events, grab, say, a status of a sensor, and make it persist in the database backend. So that's what the system looks like. And okay, features. So we'll get into the less abstract and into how this really works and what you can do with it. There's a nice plugin framework. You can very easily make your own bindings, your own actions in Java. And then, but there's a lot out there, and we'll get into that, and I'll show you the breadth of it. It's quite amazing. The rules engine, that is where you can actually write very simple scripts. They're simple. We'll get into what they look like in a moment. Very easy to work with. Typically, you don't need to write a binding unless you have something new and specific you're needing to do. There's logging mechanism. In fact, there's multiple logging mechanisms you can use that are implemented in plugins. And then the really important thing is it has a UI abstraction. So you define in the configuration files your sitemap and a tree structure of your UI widgets. And you can use some of their off-the-shelf UI tools, Android, iOS apps. There's their web interface by default, and it will construct them into UI. Or you can replace and do your own if, say, you're building a product around this and need to have that identity. And then there's the concept of item UI providers built into this UI framework, where when a sensor is tripped, say a door opens, you'll see that the UI is dynamic and it changes, and the icon has an open door icon, for example, right? So it allows for that type of abstraction as well. As I mentioned, there's web, Android, iOS, off-the-shelf things you can leverage. And I'm a command line person, so I don't know how to work these GUI tools, but it looks like a really cool and exciting designer tool that if you want to design site maps and all that stuff, apparently it's easier for most people, but I don't know how to use that stuff. So add-ons. They use a number of different terms in the documentation for plugins, add-ons. It's all the same thing. They're kind of broken into two different areas. Okay, actions, which are things like there's an HTTP add-on, which does the obvious. You can use that to access your cloud frameworks for sending events, that type of thing. Right? There's a number of services that you can use. Mail, which is an ancient notification technology still in use. Patch technology. Yes, it's patch technology. Pushover, prowl are supported. There's bindings for each of those, so you can get modern mobile notifications that way. Use Twitter to tweet that your toilet's been flushed. So there's a number, and there's many more. There's just the highlights there. And then under bindings, I talked about Bluetooth. You can do proximity events. All right, put events on the bus that a certain address came into range of the unit. GPIO. So that one's actually designed to access the sysfs Linux GPIO framework running on the actual hub device. I mentioned KNX earlier, MQTT. So you have a raw binding for MQTT where the events land right on the bus. But you can also build up a new binding on top of that, right? So you can build a more complex, purpose-built protocol for some type of sensor network that you're doing that's not just raw MQTT, or you can script up that I get this simple text message in an MQTT packet. You can just write that right into a script. Also, it's got a one-wire binding, serial. I mentioned ZWave because it's a proprietary protocol, but with this open source framework, the controller protocols are open. And so there's a whole open source project around supporting ZWave, and those are the type of things where you can go buy a commodity door sensor or light switch and plug it in and have it immediately work with this binding. So you've got a number of different ways to go, and there's probably another 30 bindings right now. Running OpenHAB. So we can beat up on Java a little bit. It runs well on x86 or ARM. Run it on both. It is a resource hog like any other Java application. It uses Jetty. It's got the OSGI container framework from eclipse.org, and but I'm running it on a 512 meg ARM v7 processor without a problem. One thing I'll note, in fact, I have a demo set up here, but I also I trust this enough running on an ARM board that it's actually deployed monitoring my mother-in-law's garage door opener with a BeagleBone Black. So, and that has been flawless for 6 months now. You can use either OpenJDK or Oracle JRE. There are some comments that there's a few bindings that are buggy, right? Relying on Oracle-isms. And so with those, I haven't run into which ones those are. You just hear the tribal knowledge that there's some that have problems. For the ones I'm using, I use OpenJDK with no problem. So you don't have to taint your system with the Oracle JRE. Yes, that's how I feel too. So yeah, it's packaged on some distros. The easiest thing, I typically use Debian on something like BeagleBone Black. I'm not religious about it. It's just what I've used forever. The CloudBees repository has all the add-ons that exist all packaged nicely and everything. In the iChart font size there, I list where the repository is for that. And my slides are up. Don't worry about that. You can get all this. Okay, we're going to look a little bit at configuration, show you how easy it is. So it's like any other well-formed application with a nice tree under Etsy for OpenHAB. That's what that represents. Under configurations, there's a config file, and then you'll see a quick mapping to all these concepts that I mentioned earlier. There's items, there's persistence methods, right? Rules, scripts, sitemaps for our UI, and transformations. We'll talk about transformations. That's one thing that we didn't cover earlier. Okay, so if we look at openhab.config, it's got all the usual stuff. Let's say you're using mail notifications. That's a site-wide type setup thing that happens in there. So this is just a little fragment. You would configure your SMTP information, et cetera, in there, and that would configure that particular add-on. So for my purposes, I use like pushover, and so my user and API key would be in this file to allow me to send events through my pushover account. Okay, little example. So this is actually showing you exact steps from the demo I'll show. This is how simple it is to define items, okay? I have a home defined with a front door contact. That's a type of an item, and it has a specific meaning, right? It has a, contacts mean that there's a state of open or closed. So they, exactly like any other type of switch. And so then I define for the UI how I want the information represented, and in quotes, the front door, and then there's a translation map, and you'll see it's the English map. And we'll get to how the transformation works, but that actually works with the transformation file that I'll show you in a moment called en.map to change the events on the event bus that come in for this particular front door contact into something that I want to print out there. Finally, in the curly brackets, we have that I have the front door contact is using the MQTT binding. And so what all this means, and it's line wrap because it's hard to show this stuff on slides, is that the broker that I want to talk MQTT to is called OpenHAB on my local network, surprise. And then the topic area is house and front door. Okay, so MQTT being publish subscribe, that should look familiar to other publish subscribe models where you have a hierarchical topic type approach to it. And then, so this I call any events, the event is house front door area, the topic. And then the state, we leave that as default. And what that means is in that binding is defined that states are open or closed is what lands on for a contact and an MQTT binding on the event bus. Finally, we have a garage door, and what I've used for that is an off-the-shelf ZWave tilt sensor, just to show a contrast. One of these is a homebrew sensor that we'll talk about a little bit. Another is showing you a different binding where I use the proprietary ZWave because you can go buy that sensor for 20 bucks in an easily mountable form and you're ready to go. And so the way it works is that we have a very similar thing that we had with the front door one, but then we say we're using the ZWave binding, and we're talking the 3 is a node ID, and all of this is well documented. When you go to their site and you look at a binding, they have a great set of examples how to formulate the item entries for that specific binding, because all of that becomes specific to the protocol that you're dealing with, the actual binding. And finally, the ZWave binding has a notion of you have to let it know what sort of ZWave class device it is. In this case, the command set to use is sensor_binary, right? And so that's one of the most common set of sensor types. So that's essentially an open-close switch as well. So OpenHAB rules, I said they're easy, but they're Java-like, but we can handle that. You can do imports, variable declarations, and then you have the actual rules. So here's just a template. Looks astonishingly like Java pseudocode there. And it's simply when you trigger on event, then execute some action. And you can set up any number of these rule names. We'll show you a little bit on the triggers here. Their item event base is one form of trigger. So you can say item, whatever the ID is that we defined in our item file, received a command. Or you can say, and this is just a small subset of what you can do in the rules, item XYZ changed from state. You don't even have to say from state to state. So you can build very complex algorithms on how you want things to interact in the home this way. But you can also do a time-based rule. So you can have, a light turn on at midnight. Right? It doesn't have to be based on an external event. And then you can also do system-based. So you want, if the system had to reboot or something, or shut down, you can take care of doing a few housekeeping items based on that. So lots of flexibility there. Actions are used, as we saw in the template, to accomplish a task. So your core actions are send a command, and what I mean by core actions is when you install the OpenHAB runtime, it doesn't have any of the pushover or any of that. That's all packaged up in separate components. They're OSGI bundles, so you install those separately, just what you need, okay? And so in the binding, or I'm sorry, the core actions, you can send a command onto event bus, you can post an update for persistence, and you can log stuff out. That's all just in the core runtime. That's the only things that are there. In bindings, there's a mail add-on, so then you get your send mail, post notification, right? Send tweet, those types of things. Those become available as you install those add-ons. So your actions that you can use in these scripts and rules extend out immediately by plugging in new things. All right, so let's look at the real world, simple the two doors we have, right? So in InHome Rules, I simply say, when item front door changed, if you saw my template for that, I don't need the optional. Anytime it changes, right? I don't care which state it's going to. Then go ahead and tell pushover, send it a message, front door is, and we have a state for that contact. We convert it to a string, okay? Now, we see the exact same thing for the garage door, because it's the same type of thing. I just need to know, is it open or closed? I need a notification. And finally, we have the transformation. I promised we would get to this. There's a default en.map that comes in the distribution, and what you see here is the actual event on the event bus is sent for a contact is open or closed, all capitalized. I find that very shouty when I'm getting a notification. It's not pleasing, so they have this nice default thing to convert it into lowercase. So you don't want your phone screaming at you. And then finally, the way we control the UI is we set up a default sitemap. You can have multiple sitemaps. And I probably didn't emphasize enough, in those the items and persistence, you can have any number of files in there defining items. It doesn't all have to be in one file. When it starts up, or when you modify the directory, it'll use iNotify and it'll reload items. So you can do this on the fly without restarting the server. So the way I do it is I simply have a default label of home that's my grouping, and within my overall home, I have a frame label of house with the front door inside of that, and then I have out in the garage door in that, and I might have multiple things in a real-world situation. So that's all you have to do with the tree structure. Pretty straightforward. So finally, a couple things that I don't show in this, but it's worth talking about, is the scripts and persistence. So the scripts, so we saw the simple rules, but you're going to want to reuse some things as you build up logic. So the scripts area allows you to find a larger body of a script and then call to that from a rule and reuse that maybe in multiple rules throughout your site that you're building this up on. Java syntax, I mean, it's the extend language is what's used. It's pretty easy to follow. Persistence, that's where you allow multiple methods to save the state. Like I talked about, if the power goes out and the smart hub goes down and you don't have backup on it, you don't want the state of all your door contacts lost, right? You want it to come back up and have some state, or switches was the more pertinent case. You don't want to have it come up and switch everything off, right? You need to have it persist. So you can use all these different add-on methods. A number of different databases are available. They all have their positives and negatives. All right, so let's talk about one of the things I did with this to demonstrate how powerful the MQTT add-on is and how easy it is to use. You saw how simple the configuration was for that MQTT contact. what I did, since I've been hacking on some ESP8266 stuff, I've been doing a lot of bare metal stuff on this, playing with door sensors, until a good friend, a past manager, has been playing with Node MCU and told me, oh, you need to switch to that. So if you don't know what an ESP8266 is, $2 to $3 Wi-Fi SoC. You buy them direct from China and through eBay and so forth. You can learn more about the latest state of that at ESP8266.com. Node MCU is this really slick open source firmware with a Lua interpreter. And it makes it very easy to do these simple sensor type things. You can find more at nodemcu.com. But it has a nice feature that it has first off, it's got a full I/O library. It's very easy to use, very attractive to the maker types that want to deal with an Arduino type access to I/O. But what's really slick is it's got a 3.1.1 MQTT implementation, and that's critical because what's packaged on older distros is like if you get current Debian, you're going to have a 3.1 compliant Mosquito. You'll have to go get a newer package typically, unless you're running SID. Most distros will have the pre 3.1.1 version of Mosquito. I forget which version that is, but it's very clear. You can look up and see all the older ones are 3.1 only. This only speaks v3.1.1. So what I did is I just took a simple read switch like you'd see in most window contacts or in the past, I guess, and hooked it up to this ESP8266. 28 lines of Lua code, right? Configures Wi-Fi, handles GPIO and switch interrupts, and then we just publish an MQTT message to that topic that we configured, right? The house/front door is our topic. And all we have to do is say open or closed in that message. So take a look at that code fragment. This is how easy it is to do a sensor on something like this on a $2 part. So you can just set it in there in GPIO trigger mode for an interrupt. After you connect to the broker, right? And when you get either edge on that GPIO line, then you just publish the message deferred from a timer. Okay. So another one, just to show you that we talked about a little bit about ZWave as a proprietary mesh network. Very convenient. You can buy this stuff. One reason it's useful to me is you can go buy in any home improvement store in the US ZWave stuff very easily and hook it up. The nice thing is, although the mesh RF protocol is all closed, the behavior and the protocols to operate the controllers is all open, and how to handle the network nodes and so forth from the controller side. So the binding for that has ZWave fully supported. I should have put that in quotes, fully supported. There are things like there's certain secure class devices that have a more robust way to include in the network that has a number of key exchange algorithms that aren't known. But for the most part, all the commodity type sensors and switches, they just work out of the box. I mentioned the controller protocols are open. You can get an Aeon Labs Z-Stick USB controller. It has built-in inclusion support. When you're building up the mesh network, part of the ZWave is you have to include each device in, get it registered with the controller. And then I use an Ecolink garage door tilt sensor. That's just an off-the-shelf, buy it from Amazon, and that works out of the box. As we saw, that was a sensor binary class device. So very simple stuff. So let me show you if it works at all, a quick demo. So I have everything that I led up to here. This could be a real hootenanny. All right, so let me get this over on here first. Oops. Oh, there we go. Hey, it worked. Very blurry cam, right? All right, so what you're going to see here, if I can get set up here, is my lock screen. Lighting's not great, but we can make this work. So what I've got here is, this is the tilt sensor, okay, in my hand, and typically you mount that to an overhead garage door, and it will, when you lay it down, that would be the open state, of course, as the overhead door goes up. I also have, you'll see the typical, tough to see it, there we go. The read switch here, where I just have it loose here, and it's in the closed state right now, okay? And what I can show you is if I go to the OpenHAB app, all right, so what you'll see here in a kind of blurry cam situation is that the front door and the garage door are both closed. And that's our state right now, because if we look at that switch, it's in the closed state and so forth. So if I put the garage door up, we would tilt it down. And what we see is I get a notification from pushover. So this is connected through my mobile router out to the cloud. I was told this would never work at a conference, but it just did. So if it doesn't work the next time, so there we go. There's the OpenHAB notification that the garage door is open. Believe me, as fuzzy as that is, it really says that, right? All right, so same thing is, take some of these off, clear them all. And then the same thing happens if I go and I take the read sensor and open it, I just got a notification that the front door opened. So we can shut the door. Just got another notification. I could put my garage door up. And there you have it. So yeah, everything's fully open source on this except for these ZWave proprietary sensors, but everything up from there shows you how you can connect with some of those things. Now I have one more. There we go. Let's get to our, all right, so I promised future of OpenHAB. So more bindings. It's sort of like the kernel where we can always count on more drivers, right? And so that's the equivalent. OpenHAB 2 is coming. And this is where things get a little bit more interesting because it is extremely bloated. I can tell you it takes a long time to start up, but I don't normally start this thing up all the time. A lot of this is very piggish. It will not run well on things with 256 mega RAM. As you might imagine, people are so focused on Raspberry Pi that they want to run on a Model A or something, and so there's work to optimize for the more constrained platforms out there. So they're trying to get to run in a 256 meg RAM one efficiently. So they have a new minimal runtime that they're working on. They're looking to possibly switch OSGI container mechanisms to help with that footprint. And then there's a new binding API. They want to incorporate some higher level concepts that they can't handle in the first version of this. And things are like dynamic discovery of devices and so forth. So there's a lot of neat things coming. Oh, and then new UI, material design. So love it or hate it, it's reality. So they're trying to fix the UIs and bring them into the 21st century, if you will. So, all right. And I even have a moment for Q&A. Or maybe I didn't leave enough time and I'm safe.